Today we are going to discuss about the chemical bonding. This is our new chapter. What are basically the bonding? Bonding is the way in which atoms join together and combine with one another. Bonding is something by that atoms are joining together. There is a force of attraction between the atoms that holds them together in a substance. That force of attraction is basically the bond between the atoms. There are different types of chemical bondings: ionic bonding, covalent bonding, coordinate covalent bonding, metallic bonding. Compounds do chemical bonding when they having electrons in their valence shell. Electrons of valence shell, for example, this is atom of hydrogen, and the first shell is the valence shell of hydrogen, because hydrogen having one electron, so that one electron is present in first shell. So this is a valence shell. First shell is valence shell because this is its last shell. The outermost shell in which electrons are present is called the valence shell. So it is very important that compounds having unstable electrons, incomplete octet or duplet. If you remember these two rules, octet and duplet, if the atom having their octet complete or hydrogen and helium's duplet complete, then they no need to combine with other atoms. They are stable, they are inert. But when their octet or duplet are not complete, they react with the other atoms to complete their outermost shell, to complete their octet. For example, I am drawing the structure of chlorine atom. First shell having 2 electrons, second shell having 8 electrons, and the last one having 7 electrons. Last one having 7 electrons in it. One, 2, 3, 4, 5, 6, 7. Okay, so there is the lack of one electron in a valence shell of chlorine. So that's why chlorine make a chemical bonding to complete its octet. So atoms do chemical bonding to complete their valence shell, till octet or duplet. If there is a helium and hydrogen atom, they follow duplet rule because they just have a one shell. So in our first shell, that is K, there is a capacity of only 2 electrons. So that's why the rule is duplet. Duplet means two electrons in their valence shell, and octet means 8 electrons other than these two elements. So today we have to discuss about the ionic bonding. There are different types of chemical bonding, but today we are going to discuss about the ionic bonding. What is ionic bonding? Ionic bonding is basically the bonding between metals and non-metals. You have to remember this bonding take place between metals and non-metals, and covalent bonding takes place between non-metals, and metallic bonding takes place between metals. So today we are discussing about the ionic bonding. That what is ionic bonding? Ionic bonding is basically take place when atoms are joined together by the transfer of electron. In ionic bonding, there is a transfer of electrons, complete transfer of electrons. Transfer of electrons. In ionic bonding, there is a complete transfer of electrons. This transfer involves the loss or gain of electrons, which results in the formation of ion. When atom lose its electron or gain electron, it will form ion. So that's why this bonding is called as ionic bonding. By the transfer of electrons, atom form ion, and due to that ions, bonding take place. In a periodic table, here you see the rough sketch of periodic table. In a periodic table, this all portion is for metals. Here the zigzag manner. This all portion is for metals, and this portion is for non-metals. So the bonding in ionic bonding, the bonding takes place between metals and non-metals. Here you can see some examples. AgCl. Ag is a metal. Silver. Ag is a symbol for silver. Silver is a metal and chloride is a non-metal. Silver chloride. Magnesium iodide. Magnesium is a metal. Iodide is a non-metal. Aluminium oxide. Aluminium is a metal and this oxide is oxygen from oxygen. This is non-metals. So ionic bonding is basically takes place between metals and non-metals. Here is aluminum take place in this group. So that aluminum is basically a metal, that is not a non-metal. In this position, aluminum take place. Okay, so ionic bonding takes place between metals and non-metals. Remember this, always if there is a bonding between metals and non-metals, so you quickly pick the point that it is a ionic compound. Here you can see the example of one ionic compound, that is sodium chloride, that is table salt, the common salt that is used in your houses. So we are taking the example of sodium chloride to better understand what is ionic bonding. Sodium having atomic number 11, atomic mass 23. Chlorine having atomic number 11, atomic mass 35.5. For example, this is an atom for metal, sodium metal, and this is an atom for non-metal, chloride, chlorine. This metal and this non-metal combine together by the transfer of electron. Always metals lose their electrons because they having high electropositivity, and always non-metals takes electrons because of their high electronegativity. So metal, that is sodium, will lose its electron, and chlorine, that is highly electronegative, take electron from this sodium atom, and they will combine together in the form of ions. Why sodium atom gives its electron, we are going to discuss this. Here you can see the atomic structure, the electronic structure of sodium and chloride. In a first shell of sodium, there are 2 electrons. Here you can see 1 and 2. In a second shell, there are 8 electrons, 1, 2, 3, 4, 5, 6, 7 and 8. And in a third shell, there is just 1 electron. These are empty portions. Okay, here is just 1 electron in the third shell of sodium, and this is the atom for chlorine. First shell having 2 electrons, second shell having 8 electrons, third shell having 7 electrons, and 1 space is empty. So as I told you that every atom wants to complete its valence shell. If the atom is helium and hydrogen, they want to fill 2 electrons in their outermost shell, the duplet rule. If the other atoms of the periodic table, they want to fill their outermost shell with the 8 electrons to complete their octet. So here you can see the chlorine having 1 less electrons to complete its octet, and sodium having 7 less electrons to complete its octet. So as the highly electropositive, sodium will lose its electron, and that electron is gained by this sodium atom. In the next step, when sodium will lose its one electron, here you can see there is lack of that shell which is in the previous figure. Here are three shells. When sodium lost its electron, it also lost its last shell because there is just one electron in that shell. So if sodium lose that electron, then it will also lose the shell. When sodium lose this electron, it will become positive ion. It will become positive ion. So while I am drawing the electronic structure, I made the bracket and after that I have written the sign. If I will ask you the question to write the electronic structure of ionic bonding, so you have to draw like this. Show the ions at the top. Okay, so as sodium having 7 protons and 7 electrons, but when sodium lose its one electron, now it having 10 electrons. By the loss of one electrons, it takes positive charge. That positive charge is called as ion. That positive charge is called as ion. If the charge is positive, then it is cation. Next, you can see that one electron is taken by this chlorine atom. Now it will become a ion. Ji Muskan.
What is cation?
Cation is the name of the positive ion. I am saying by the loss of one electron, sodium contains positive charge. So when any atom having positive charge, it is called as cation. This chlorine atom takes that one electron. Here you can see the electron is taken by this chlorine atom. When the chlorine atom takes electron, it will contain negative charge and becomes chloride ion. Chloride ion. The chloride ion, the negative ion is called as anion. The negative ion is called as anion. So now you can see here, chlorine, as we said before, having 11 protons because its atomic number is 17. Sorry, atomic number is 17. So it having 17 protons and 17 electrons. But by the gain of one electrons, now it having 18 electrons. So by the take of one electrons, it contains negative charge. That negative charge is called as ion, and specifically the negative ion is called as anion. So ionic bonding take place by the formation of ions. So now you can see here the sodium positive ion and the chloride negative ions are combined together and make the bond. In this way they combine together and make the bond. Mostly in exam, the dot and cross structure is asked by you. So you have to draw a dot and cross structure. I have make the, you can see here I have drawn the both the dot structures, but you have to make a dot and cross. In one you have to draw dots and in a second one you have to draw the cross. Show electrons with the cross. Like this, I'm drawing here. This is a sodium atom. First shell having 2 electrons, so you have to show it with the cross. In a second shell, there are 8 electrons, so you have to show these electrons with the cross. So when you are showing the bonding between 2 atoms, so draw electrons of one atom with the cross and electrons of the other atom with the dot. Always remember this, you have to draw as a dot and cross structure. If they do not ask about the dot and cross structure, so you have an optional case that you can draw with the dots. But it is very good to draw as a dot and cross structure because mostly in exam they ask about the dot and cross structure. Okay, so dot and cross, its name is because the electrons of one atom is shown as a cross and the electrons of the other atoms are represented as a dot. Next, by the transfer of electron, ionic bonding is formed. One atom has lose its one electron and the other atom has gain that electron and becomes negative ion. What is electronegativity? Electronegativity is basically the ability of an atom to attract a sheer pair of electrons towards itself in a molecule. Sodium having the ability to attract a shared pair of electron, to attract a pair of electron, this chlorine atom is electronegative. So that's why it attracts the shared pair of electron of the sodium. That's why sodium loses its electron and that electron moves towards the chlorine atom. Metals having low electronegativity, they are electron givers. They lose the electron, they give the electron. Non-metals are highly electronegative, they take the electrons. That's why metals lose electrons and non-metals gain electrons. Ji Zimal.
Miss, do metals always lose electrons?
Metals always lose electrons.
Okay.
Because of their low electronegativity, high electropositivity, metals always lose electrons and non-metals always take electrons. Next, here you can see when there are bunch of atoms, because there is not just the one bonding NaCl. No, in the compound there are, for example, you are taking a table salt. That table salt contain many bondings, many units, many particles of the sodium chloride. So for example, this is the one sodium molecule compound, this is the another sodium chloride compound, and this is the third one. You can see the three particles of this compound. So when in a one container at a one place there are many units of the sodium chloride, they will make a combined structure. Here you can see positive negative, positive negative, positive negative, positive negative. Here again negative, here again positive, positive, negative. In this way they combine, and this combining structure of alternate charges, alternate ions is called lattice, and this structure is called as lattice structure. This arrangement of ions as a opposite ions is called lattice, and that's why structure is called as lattice structure. What is specifically the lattice is the regular arrangement. Lattice means the regular arrangement of constituent particles. What is constituent particles? Atoms, ions or molecules are called as constituent particles. So in a lattice, the regular arrangement of constituent particles takes place in a 3D structure. 3D structure. Here you can see that 3D structure in a next figure. Here. This is the lattice, crystal lattice of sodium chloride. This is a crystal lattice of sodium chloride. So here you can see the alternate atoms. Red color is for sodium and the green color is for chloride. So this is called as lattice. If you see the stick and ball structure of this lattice, this is a stick and ball structure of this lattice. So you can see the bonding is shown with a stick and atoms are shown as a balls. So in this manner, alternate atoms, you can see alternate ions are combining. This is a positive ion, this is a negative ion, again positive, then negative, then positive, then negative, positive, negative, positive, negative. So in a lattice, alternate ions are combining together and making a lattice structure. So in ionic compounds, they form a lattice structure. They form a lattice. Next, writing ionic formula. How we can write the ionic formula? This is a very important thing, how to write an ionic formula. Here you can see the chemical name, that is magnesium chloride. Magnesium chloride having a formula MgCl2. Why I have written this 2 at the bottom? Lithium oxide. Lithium is a metal. Oxide comes from oxygen. So lithium oxide is also an ionic compound. Metal and non-metals are combining. They are forming ionic compound. Formula of lithium oxide is Li2O. Why I have written 2 here? How I come to know that I have to write 2 at the bottom? So while you have to write the chemical formula of ionic compound, you must remember the valencies of the some group elements. Lithium is from group 1 and oxide is from group 6. This is metal and oxide is non-metal. When metal and non-metal are combining, they will form ionic bond. Always remember this, ionic bonds form between metals and non-metals. Ionic bond will form. Here you can see the rough sketch of periodic table. Here, this is a group 1. Group 1 having +1 valency. Because the elements of group 1 having 1 valence electron in their outermost shell, so they have the ability or capacity to lose 1 electron. So when they lose 1 electron, they contains +1 charge. You have to write 1 then sign. Okay, because while we are writing the valency, we have to write number first, then charge. 2 plus, 3 plus, 3 minus, 2 minus, 1 minus, in this way. Okay, second group elements having 2 electrons in their outermost shell, as we know this. So that's why they lose 2 electrons and contain +2 charge. Elements of group, this is the group 3A. Aluminium comes in this group. Aluminium is a metal. Here aluminium take the position below the boron. Here boron, here carbon, below the boron, and this is a zigzag structure. Here is the zigzag structure. So aluminum comes in a metals. Yes, this all portion is for metals and this all portion is for non-metals. Okay, so aluminium having 3 plus valency. Nitrogen, oxygen, fluorine, phosphorus, these groups. This is a group number 5A. This is a 6A. This one is a 7A group. And this is last 8A group, or inert gases or noble gases. So these 7A groups having a valency 1 minus, because they have a capacity to take electrons, that is 1. Because they having 7 electrons in their outermost shell. So they take 1 electron and become stable. This group elements having 6 electrons in their outermost shell. So when they take 2 electrons, they will become stable. The element of this group having 3 electrons in their 5 electrons in their outermost shell, when they take 3 electrons, they will become stable. So when these metals are combining with these non-metals, they will make bondings. So you have to remember the valencies by knowing that how much electron they can lose and how much electrons they can accept. Here you can see, okay, one example how to write a chemical bond between ionic compounds. Lithium oxide. Lithium means Li. Symbol of lithium is Li. Oxide is oxygen, O. Oxygen having a valency 2 minus. Here you can see oxygen in this group, in group 6A, having a valency -2, because oxygen having 6 electrons in their outermost shell and the lack of 2 electrons. So oxygen needs 2 electrons to complete it oxide, and because of electron negative, it will take electrons. And metals, due to low or a weak electronegativity, they will lose electrons. So lithium is from the group 1. This is a group 1, and here you can see the lithium. So lithium is from group 1. That's why having +1 charge, +1, 1. Here 2 minus. So how you can balance these ions? If you having 2 lithium atoms, then these ions will balanced. If I take 2 lithium atom, 1 atom and 2 atom, then these 2 lithium atoms will balance this -2 signs. So here 2 atoms of lithium and 1 atom of oxygen, that's why their charges are balanced. -2 and 2 plus. That's why their charges are balanced and they make a chemical bond. There is another way to represent this like this, having a valency 2 minus and having a valency 1 plus. So there is the change of the valency at the bottom of the two elements. So you have to write its valency at the bottom of this atom and the valency of oxygen at the bottom of the lithium. So in the same manner, you can suppose to write a chemical formula by cross exchanging the valency, or think like this, that to balance this valency you need 2 lithium atoms. Now take another example, potassium nitride. Potassium is K and nitrite is 3, -3. Why this is -3? Because you can see here this group elements having a valency 3 minus. So that's why I have written here 3 minus, and potassium is from a group 1. Here you can see the group 1. So that's why potassium having a +1 valency. So how can I balance this -3? If I will take 3 atoms of potassium, then I will balance this valency. So that's why I have taken 3 atoms. Here you can see 3 atoms of potassium and 1 atom of nitrite. If there is a single N, you have to name this ion nitrite. Remember this. This is a one way, or another way to write the ionic formula is cross exchange the valency. Potassium having a valency +1, so you write here, and nitrite having a valency -3, nitrogen having a valency -3, right here. So K3N1. No need to write 1 here. This is a wrong way. No need to write 1, because if there is nothing, then there is a 1. In a same manner, you can write the formula of ionic bonding of sodium chloride. Their valencies at the top and cross exchange of valency to balance the charges. Aluminium having 3 plus valency, oxide having -2. So how you can balance these ions? If you take 2 atoms of aluminium and 3 atoms of oxide, then you are able to balance the +3 -3 charge on both. Or cross exchange the valency of oxide at the bottom of the aluminium and valency of the aluminium at the bottom of this oxygen. So in this way you can balance the valencies. Write the chemical formula. Clear? So it's your homework to write the chemical formula of calcium chloride, magnesium oxide, potassium oxide, lithium chloride, potassium fluoride. It's your homework to write the chemical formula of these compounds, and I am also sharing with you the assignment. That will be the assignment number 3. You have the time just till the 6 o'clock.